Welcome to Brain Vision.
In this problem, we've got this industrial laser, and it's trying to burn a hole through this piece of metal here. And so it's hitting that metal, heating it up, and we know that the average intensity of this laser, that is S bar, average intensity, 1.23 times 10 to the 9th watts per meter squared. So that many watts applied over every square meter of this metal is going to burn a hole through it. And what we're attempting to find in the first part here is the RMS value of the electric field. That's the root mean square value of the electric field. Well, we have an equation that will relate these two things. It's actually the average intensity equal to C times epsilon naught times the ERMS squared. Now, C and epsilon naught are just constants. The speed of light, 2.9979 times 10 to the 8 meters per second. And epsilon naught, the vacuum permittivity, 8.85 times 10 to the minus 12. And we've got units of coulombs squared per Newton times meter squared there. So all we need to do is start plugging these things in. We'll be able to solve for the ERMS. First thing I'll do is rearrange this equation. So since we're solving for ERMS, I want to divide by C epsilon naught on both sides. And I'll write that down here. ERMS squared is equal to average S over C epsilon naught. Then if we take the square root of both sides, we're going to find that the ERMS is equal to the square root of average S over C epsilon naught. Now we have all these values here for each of those things, so go ahead and just plug that in. I'm going to plug those all into my calculator, and we'll get something like 6.81 times 10 to the 5. And let's make sure we check our units here, because it's the root mean square of the electric field. Then we're expecting our units to be newtons per coulomb. That's the ERMS for this industrial laser. Now in part 2, we're going to be doing something very similar and look for the magnetic field of the electromagnetic wave emitted by this laser. And that's given to us by a simple relationship between ERMS and BRMS. BRMS is equal to ERMS, where E is the electric field, B is the magnetic field, and a simple factor of C there. So electric field divided by C is equal to the RMS of the magnetic field. So let's go ahead and plug that in now using that ERMS that we just found. 10 to the 5. We divide by C times 10 to the 8 meters per second. I get 2.27 times 10 to the minus 3. And those units, we have newtons per coulomb divided by meters per second. That turns out to be Newton seconds per coulomb meter, which is also just units of Teslas. So Newton seconds per coulomb meter is equal to T. So I'm just going to rewrite our units down here as Teslas, since it's the magnetic field.